this was out of 7,291 patients with lung adenocarcinoma. We found 59 patients that had mutations in either RRAS or RRAS2. These mutations were typically mutually exclusive with other major lung cancer drivers like KRAS, EGFR, ALK fusion. And interestingly, they occurred in hotspots that the most commonly occurred in hotspots that corresponded to the KRAS Q61 mutational hotspot. So in RRAS, that is Q67, and in RRAS2 is Q72. And when you do the alignments, those correspond to the same residue as KRAS Q61. And obviously that's very suggestive that they're having the same effect on the RRAS and RRAS2 proteins that the Q61 mutations have on KRAS and NRAS. And indeed, we modeled those in BAF3 cells and showed that they conferred IL-3 independent growth as a kind of basic assay of their oncogenicity. We've gone on to also look at the sensitivity of these mutations to RAS, well, different ways of targeting tumors with RAS mutations includes MEK inhibitors, ERK inhibitors, and now RAS inhibitors. And we tried all three. The ERK inhibitor, ulicertinib, the MEK inhibitor, binimetinib, and the pan-RAS inhibitor, RMC-6236, which I think now has a name from Revolution Biosciences. And these mutations are sensitive to these inhibitors, much like KRAS mutations are. We also put these mutants into human bronchiolar epithelial cells, HBECs, and showed that they induced growth in vivo and when xenografted into immunodeficient mice, NSG mice. So it, all these lines of evidence, and then if you treat the mice with the pan-RAS inhibitor, you get in vivo arrested growth of these HBECs in vivo. So all these things point to these being oncogenic drivers in a small subset of lung adenocarcinoma patients. It's become apparent that there are these different driver alterations that activate MAP kinase signaling and are typically mutually exclusive, but it hasn't been defined in 100% of cases. So there's like a piece of the pie chart, so to speak, that still is kind of unclear what the driver is. And, this work kind of, makes that piece of the pie chart a little bit smaller, because now we know, small percentage, it's activating mutations in RRAS or RRAS2. Well, one of the things that we're interested in is uh, looking at additional members, additional genes that are involved in RAS signaling, either in a positive way or a negative way, uh, that have not been uh, screened in large numbers, to see if there are some recurrent hotspot mutations in such genes. Uh, so to kind of, I mean, RAS signaling is very complex. Uh, there are many members, and the it's possible that other members that have not been extensively studied may have mutations, and if those mutations are at the 0.5% level, uh, they will not be recognized in smaller studies. You need large numbers. So that's something that we're interested in.